In the last two sections, we've talked a lot about what correlation is and what the equation is about. Let's take a look at an example problem and kind of discuss in the context of the hypothesis testing method how you might approach a correlation. Now, correlations um, can have a value even though two variables are not related. And so in hypothesis testing, we start with the null hypothesis that there is no correlation. So the null is that the correlation coefficient is equal to 0, which means that variables y and x are not correlated. The alternative is that there is a correlation coefficient. It may be positive, it may be negative, but it's something other than 0. So let me pull in an example. In this example, we have the returns of December to January, and I go all the way back to 1951. And so we can see, for example, in 1951, if you bought a portfolio of stocks, this is the S&P 500, or it's a large portfolio that represents the entire U.S. stock market, you'd make about 3.9%. That's an incredible return for 1 month. In the following month, in January, you would see that you would have made a 6% return. Now, we can see that this is positive and high, and this is positive and high. Is there a correlation? Well, that's only one observation. I've got some 62 observations here that we can compare. So we need to first calculate the correlation coefficient. Correlation coefficient in Excel is CORREL, and then it just asks for the two arrays. Now, in Excel, it doesn't allow us to include variables, or at least in this calculation. So we put in the first array, which is B2 through B63, doesn't include the label. And then the second is C2 through C63. Now the arrays must have the same number of observations or you'll get an error. We hit enter and we see that there is a positive correlation coefficient of 0.21. Now while we're here, let's do this another way. We can use our data analysis tool pack, and we're going to use the correlation tool in that data analysis tool pack. And the input range is just your entire array. Now notice that if we had more than one variable, we could have used more than one variable. We do have labels, and I'm going to put this output here. So we can see that the correlation between December and January is 0.21. The correlation coefficient between December and December is 1, and the same with January and January. It's 1 because there's a perfect positive correlation. This box is empty because the correlation between December and January is the same as December and January. So it would be redundant to put the same 0.21 up in this top corner. Now, this tells us that there is a positive correlation, but it doesn't tell us the strength of the correlation. And in order to find the strength of the correlation, we need to first ask if the correlation coefficient is significant. So we need to go to the last table in your notes, and this is the Pearson correlation table, and I'm opening that now. So within the Pearson correlation table, we see that on the left-hand side we have the number of observations. In this case, we have 62 observations. Now, we come down here and we can see that we don't have 62, we have 60 and 65. So to be conservative, we're going to back up to 60. This third column represents the 95% confidence interval, or the alpha of 0.05, but it's split between two tails, and so 0.05 divided by 2 is 0.025. We come down here, so for a correlation coefficient to be significant, it needs to be at least 0.254. Remember, we're going to be comparing the absolute value again. So now we can go back to our hypothesis testing, and we can start with the null hypothesis that the correlation coefficient is equal to 0. The alternative hypothesis is that it's not equal to 0. We calculated the correlation coefficient statistic, and we found it to be 0.21 based on an alpha of 0.05, which we'll use consistently from here on out. We find that they are critical, or the critical correlation coefficient is 0.254. So 0.21 is less than 0.0254, and we're going to be comparing the absolute value. So if it was negative, we would just ignore the negative. And we would say that there is not a significant correlation, or we would fail to reject the null hypothesis. This would mean that there is not a statistically significant correlation. Now, the claim is that that you can predict January's returns by December's returns. So if January was high, December will be high. If January is low, December would be low. Because there is not a statistically significant correlation, this evidence does not support the claim.